It's important to understand that networks, and especially in today's world, are going to change. They have to. They have to adapt to the customer base need. So whenever a network changes, it may need to be reconfigured or data rerouted to serve that ultimate need. This paramount should be of your concern, especially when it comes to network separation. Network separation provides separation between different parts of the network, entry and exit, or primary and D and Z. Options to accomplish this network separation is obviously to physically separate users by connecting them to different switches and routers, or possibly even air gap a switch. That will accomplish the separation that you need. However, sometimes it is not the most elegant of solutions, and sometimes it's not even practical. When configuring your network devices, especially your switches, you'll want to protect against broadcast storms. This is basically loopback protection. It uses the IEEE standard 802.1d spanning tree algorithm. It determines which switch has multiple ways to communicate with that host, and then it determines the best path to communicate to that host, and then blocks all other paths. Also, VLANs. VLAN management, when physical separation is not feasible, is the best way to segment up your network and segment them into logical groups of physical devices. This way, you can have your users spread across the world and still be logically connected together via VLANs. Some of the general principles for managing VLANs are that a VLAN should never communicate with another VLAN unless they're both connected to a router, and changes any default VLAN, and you should change any default VLAN name. It's also a good practice to disable VLAN 1, for instance, and assign the default VLAN to another number. You'll also want to configure VLANs so that public devices are not on a private VLAN. This is where you'll see the employ of internal and external DMZs, for instance. It's important to disable any unused ports on your routers and switches. That means to turn off those ports that are not required on the network themselves. All these ports should be secured before any switch or router is deployed, and your network administrator should issue the shutdown command to each unused port, physically going into the configuration of the device and issuing the shutdown command. Don't rely on it being defaultly shut down. This can and does provide a somewhat false sense of security. Next would be MAC limiting or MAC filtering. This simply limits the allowed devices to connect to any one given port. You can limit it to one and oftentimes maybe two. This is one of the best methods to physically protect the port on the switch itself from a malicious user. Some of the options that you have with MAC filtering is static MAC filtering. This is assigning a one-to-one, a known MAC address to a known port. Dynamic MAC filtering, when you don't know necessarily the MAC address that is permitted, you will open up for dynamic MAC filtering, and then the first device that plugs into that port will then get mapped to that port and all others will be denied. Or sticky MAC. This is often found on Cisco devices. The MAC addresses are automatically learned and stored along with any other addresses that were learned prior to using sticky. This allows for a more dynamic and fluid environment. However, it is not the most secure of employ. Next would be 802.1x. This is the highest degree of port security. It implements port-based authentication. It blocks all traffic on the port-by-port basis until the client is authenticated to the environment. If the MAC is not stored in the MAC table of the environment, it will never be able to pass traffic. 802.1x is by and large the best standard to employ for network-based port authentication. There are 6 steps. To successfully navigate the Security Plus examination, you should be familiar with these 6 steps of the 802.1x process.